matrices, and it's called row reduced echelon form. And we're going to go over that today, and it's something super nice, especially using your calculator. So, a matrix is in row reduced echelon form, RREF, when it satisfies the following conditions. Memorizing the conditions, I think, is more complicated than just understanding what it looks like. But the first non-zero element in each row, called the leading entry, is 1. So notice in this one, 1, 0, 0, 1, 0, 0, 0, 1. So the first number has to be 1 if it's not a 0. Each leading entry in a column is to the right of the leading entry in the previous row. So this one is here, but then this is to the right, this is to the right. Rows without zero elements, if any, are below at the bottom. The leading entry in each row is the only non-zero entry in its column. So notice how this is a 1 and the rest are zeros. So that's what it looks like. And it's very helpful in solving systems of equations. So to use row reduced echelon form, you will need to put a system of equations into an augmented matrix. Augmented matrix is just a fancy word for put all these numbers in a matrix. So like, we would do 1, -2, 3, 7, 2, 1, 1, 4, -3, 2, -2, -10. And then if you're doing it by hand, typically it's nice to put some dots there, because that's where your equal signs are. Right? And I'm actually gonna, not do that. Can I go this way? Okay. Oh, whatever. I'll just do it again. And then, when we did systems of equations, we did graphing and substitution and elimination. You know how in elimination we multiplied whatever we wanted to multiply things by, and we added and subtracted rows? And it really doesn't matter if this row is up here or down here, right? So when we have this augmented matrix, our ultimate goal is to get it in row reduced echelon form, and we can do so by swapping, adding, subtracting, and multiplying rows. So for example, you know how we want 1 in the first row and then zeros all the way down? I could take row 2 minus 2 times row 1 and throw it back into row 2. So if I take row 2 and I'm subtracting 2 times row 1. 2 times row 1, this will get a 2, right? 2 times all of this, 2. 2 minus 2 gets me 0, which is what I wanted, right? I want a 0 underneath this, right? 2 times minus 2 times row 1 is going to be 4, so that'll be 5. So that's okay. The 0 is what we wanted at first, right? And then whatever numbers we get here, and you do the same thing here. And then eventually, if we eventually got that to 0, now we'd want a 1 here. Well, guess what? We just do 1/5 times row 2. Right? And as long as we times this stuff by 1/5 as well, that's where our equal sign is. Everything stays the same. It's basically just doing elimination a bunch of different ways over and over and over until you get ones everywhere where you want them. Now, in college, we did that by hand repeatedly because there were no calculators allowed. And we had to show that we knew what row, what's it called? Row operations were. But we have a better way to do it. Absolutely. So, in my calculator, I'm going to go to second matrix. I'm just going to edit my first one. This is going to be a 3 by 4. Oh, and then 1, -2, 3, 7, 2, 1, 1, 4, 2, 1, 1, 4, -3, 2, -2, -3, 2, -2, -10. Okay, put that in there. We're going in the second matrix, going over to the math. Up. Where is it? Where is it? I'm looking for it. There it is. Do we see it? Oh, whoa. Hello? Maybe it's easier to go up. RREF, row reduced echelon form. Bang. And then I'm going to have to use the matrix A. Oh, man. 2, -1, 1. So if we RREF it, we end up getting, I just said it out loud, 2, -1, 1. And then the rest of this is in row reduced echelon form. Woo! I just solved it for us. This says, hey, what is this column? X's, 1x or just x equals. This column is y's, 1y or just y equals. This column is z's, 1z equals. Oh, man. Holy crap. Whoever invented matrices is a genius because a computer can do that super fast. Imagine if we had like a bunch of equations, how fast a computer could do it. Because we have this. Pretty crazy, right? And if you plug 2, -1, and 1 into all of these, they should all work. Nice shot, I guess. But maybe I'll here for a second. Let's do one more because it's fun. Why not? So, oh, hey, we're going to do another 3 by 4. Edit. I'm okay with that. 2, -4, 5. -33. Uh-oh. Pay attention, the x is here. So 1, or not 1. I know my numbers. 4, -1, now 0, because there's no z. -2, 2, -3. That all look right? Looks right to me. Oh wait, is there a? Whoa, 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 whoa. And it's the letter B, if you guys want to know. So if you do like, oh, if you go alpha B, oops, wrong one. Woo! And then, hey, I like fractions. We know what 0.5 is, but maybe if you had a more complicated one, you could hit math, and then the first one is frac. Puts it in fractions. So -1/2, 3, -4. And it was 1, 0, 0, 0, 1, 0, 0, 0, 1. That's a really fun, quick way to find answers to those, huh? You can do it with 2x2s as well.